All right, guys. Let me put this in focus really quick. I know you guys probably have a hard time seeing this, but if you guys can, make sure you guys grab a handout from each of those stacks. There's about 5 stacks of paper. And this is the warm-up problem that I want you to try. It's a little hard to see without the light, but I don't want to shut off the lights right away. But if you have this, it should say example 1, calculating snowfall. I want you to work with a partner, at least one other person that you can find. Or you can work solo, but I would rather you try working with someone to try to figure this out. I think it's kind of difficult, a little tricky. So go ahead and try to work this out here. Read over the problem and work this out with a friend. Okay. All right. So good luck, Ashley. If you want, you can work with Elena. Elena, if you want, you can work with Ashley. Yeah. Just so you have a partner, so you're not working completely by yourself. And I'll give you guys like 5 or 10 minutes to figure this one out. And yeah, you're right. If you think this is from the book, this is entirely from the book. What helps is to focus on the units. The next problem I'm going to give you is not really good with the units, but this one's really well written with units. On the y-axis, what's the units on the y-axis?
Inches per hour.
Yeah. And then I know it's really tricky. It just says 3 a.m., 5 a.m., and 7 a.m. But what units are those actually in?
Hours.
Those are in hours. So if they're talking about find the total amount of snow that falls during the storm, what do you think? What unit would they prefer? Or what not prefer between those two? I mean, what unit do you think they're looking for? They're probably going to look for it in inches. How do you find out an answer that gives you only the unit of inches, considering what information we have? Okay, so that's the trick. Think about that. Right? It's a lot. It sounds really convoluted, but it's a lot easier than you might suspect. Okay, and then go ahead and just grab one of each of those piles. And then grab these bulletins too, guys. AP student. I think everyone's supposed to have that for your AP classes. It gives you like a timeline of the schedule for when you got to pay your dues, when the exams are going to be administered, and so forth. All the AP teachers are required to give you guys those, including me. So I want you guys to have that. Where'd you get that from?
I just calculated the area behind this.
No, just go ahead.
I feel like that's good.
Now with yourself.
So, like, in the simple sections, it's like
Yeah.
like the area of that, and then I'll just have to and then again at that.
Oh, yeah. I was like, I know what that is.
You step on this one. You guys need more time? Give you indicative that you might look. And you found 3 different values for the 3 shapes. Alright. You guys need help? You guys are overthinking it. Let's see what you guys got. So you got 1.2 times 3. Yeah. Okay, you're on the right track. You're finding areas, right? And just figure out a shape that works for that. Or go with that shape. Give you guys like another minute, and I'll go over the answers with you. All right, I'm gonna. All right, I'm gonna go ahead and go over kind of where I was going with this. I think you guys had a good realization that you guys were trying to find areas or the area under the curve. In fact, if you found the area under the curve, let's take a look at this one individual shape here. What did you guys recognize this as a shape as? Or a square or yeah, I think it looks like a square, but according to the numbers, the dimensions don't like. I would say the height of this or the length of this would be how tall. This part of the square rectangle right here. Yeah, this is technically 1.2 inches per hour if we had to be really technical with the units. And then across from here to here is a little tricky because the time scale on the bottom isn't really quite clear. It says 4 a.m., I presume, 5 a.m., 6 a.m., 7 a.m., 8 a.m. What did you guys get for a dimension here for like the width of this rectangular square?
3.
How did you get 3? Yeah, go ahead.
5
Yeah.
a.m. to 6 a.m. is 1 hour.
Yeah, that's about an hour.
7 a.m. is another hour.
Uh-huh.
And then 7 a.m. to 8 a.m. is another hour. 3 hours.
So if I did the math there, I tried finding the area under the curve, and it's asking for the total amount of snow during this storm. Let's see if this works out, and I get an answer that is maybe within just some kind of unit of measure. Measuring like the height or the length of the snow, right? And I think I'm going to run into problems with this per hour thing or these hours here, but if I multiply the two, 1.2 inches per hour, you should see if I multiply those including the units, the hours actually cancel out, and I get a value that is only a matter of inches, which is great. That is actually very logical. That should tell me the amount of inches of snowfall, right? So it makes sense. I multiply the rate at which the snowfall comes down. It's 1.2 inches per hour. I multiply by the time that occurred within that rate. If I multiply those two, I should just get how much snow fell within those 3 hours. Make sense? I'm going to give you a more comprehensive answer that I wrote up last year. So not to confuse you, let's break down a few things that I also changed as well. You don't have to do this, but I typically find it's a little confusing with the AM. I think it throws people off a lot because they're like, I don't know the units. So instead, what I did was I crossed those out and I said, that's the 0 hour, the very 0 hour we're kind of looking at. After 1 hour, that's 1 hour, 2 hours. So I changed these increments by actual values of hours. You don't have to do that. I chose to do that. Okay. But I think you guys were pretty good in not having to do this like me. I had to do that to see it, visualize it. Then we also found the area of this rectangle, which was about 3.6 inches. What's new though, is I had to find the area of this section here. And what shape does that look like? Which geometric shape does that most resemble this section right here? Yeah, and specifically maybe a right triangle, right? So, what's up? Go ahead,
It
Stephanie.
doesn't really matter if it was the right triangle or not.
That's true.
Because it is the same formula. So.
Yeah, it's the same formula for every triangle. It's 1/2 times base times height. And then the height for actually all three of these sections is 1.2 inches per hour. I multiply it by the base, which I think is from 3 a.m. to 5 a.m. I said that's 0 to 2 hours. It doesn't really matter. Either way, it's 2 hours. So I multiply, I know it's really hard to see, but that's 1 times 2 hours times 1.2 inches per hour. And at the very end, I got around 1.2 inches. And then for the other side, did the exact same thing, only the increment was a little bit bigger for the base. This is from like 7 a.m. or 8 a.m. to 9 a.m. to 10 a.m. to 10:30, I estimated. That's about the middle. But if I looked at my increments, this is technically hour 4. This is the 5th hour. So 5th to the 6th hour is 1. 5th to the 7th hour over here. Like I'm going by my own increments now. That's 2 hours. That's about 2.5 hours for the base. So I multiplied, 2.5 hours to the height, which is 1.2 inches per hour. And I multiplied by 1/2, and I got about 1.5. And then I think all you guys got this too as well, this concept of just adding the areas together, and I got about 6.3 inches, okay? On your exam, if you got around the same ballpark, I think you would have gotten about full credit anyways, or about close to full credit. Now, if we're talking within the realms of like 36 inches, or maybe an order of magnitude by 10 to the second power, like we're looking at 60 or 70 inches, you're probably not going to get the credit, okay? But if you can stay within a ballpark around the same order of magnitude, then you should be okay, right? Any questions so far? Why don't we try a similar? Oh, I almost gave you the answer here. This is actually my little mini key. Go to this one over here. The only bad thing is I think the person that wrote this up really did not pay attention to the units, okay? It's the same concept, but just read it to yourself. Conceptually what the problem is asking for. It is going to be an area under the curve, but with the contextual clues that you have, how are you going to find out the area under this curve? That should be a little bit more tricky. Use your other handouts as maybe a clue. You don't have to do anything with those handouts, but which handout is best going to help you visualize what you're going to have to do? And if you can, go ahead and try to solve for it. I'm only going to give you about 5 minutes to solve for this guy, though. This one's a little trickier. Look through all your handouts. Just a little bit more time. A lot of your handouts should help out, but I would say one, just visually speaking, should kind of give you a good idea. Did you figure it out already, Stephanie? Oh, you're already using that. That's the advanced one. Yes. I'm thinking this one would help a lot. There. Oh, you're dividing it into twos, okay. And then what shape or Oh, okay. All right. Wow.
I'm using them.
Okay.
I'm using them.
How does this?
And then you put it there. And then you
What shape are you creating to estimate the areas of these curves? Did you already read this section or no? Yeah. Oh. Well, I'm still going to be great. That's amazing. Really good. All right, let's figure it out. Have you solved for this problem? Or, conceptually, where you can start? I would say maybe look at, not this one. This one's a little bit far off right now. I would say look at that one. How are they estimating the area of the curve? What shapes are they creating out of the areas of the curve? It's not going to be perfect. Very good. And I'm really excited you kind of caught on. What shapes do you realize are they making any of these curves to estimate the area? Yeah, so they're spread rectangles. Should this data table be of help to you to make these areas of the rectangles? That's where you just optimized. Oh, yeah. Oh, you guys are quite listening. So I think we recognize in one of the handouts shows you to make these into rectangles. Then ask yourself, what is this data table here for? Will it be of use to me? Okay? To help me solve the areas of these rectangles and create. Give you guys some light here. And I'll say this, depending on how close your answer is, I will allot you some extra credit if you can find out the area under this curve. Try not to use the units though. Whoever came up with the units is I don't think they're very best at conversions and dimensional analysis. In fact, when I was learning this in calculus, I think my calculus teacher didn't really emphasize on units. But if you guys know me from chemistry, you'd realize how strict I am on units. Because it should work. Everything works well. Everybody have a good winter break, by the way? Did you guys do anything fun for yourself? Fulfilling? No?
I got into the Switch for Christmas. That was awesome.
Really? Yeah, my girlfriend really wants to switch. So I don't think I should afford the money to do that right now. But what games do you get?
Just Super Mario Odyssey so far because that's what it
That's all you need. That's all you need. Oh, how much did you get it for with
I don't know. My parents bought it.
the bundle? Yeah, that's really good. I think I'd rather have that one than the Legend of Zelda bundle, just because Mario Odyssey seems more appealing.
Yeah. I've had the majority.
You've had Breath of the Wild?
No, not Breath of the Wild. Odyssey. I've been playing it.
played it over break.
Have you had time since school started to play?
Not since school started, but I did a bunch of it.
Yeah, Odyssey still looks really good.
It is.
Yeah.
Yeah.
They say it's more in vein with Super Mario 64 than it is Mario Galaxy.
Yeah.
I
The
love
Galaxy is like pretty linear. Oh, the other like real.
open world, more explorative.
They're like
Odyssey.
close course versus like exploring stuff, and Odyssey is really exploring stuff. And
When I first booted up Mario 64, I wasn't a fan of the open world gameplay level design. But then after like 2 hours, I really saw the beauty in it. Yeah, and I think
I only like played 30 Mario games so far, and that was New Super Mario Bros. For the DS, and then like Super Mario Galaxy, though I never finished that.
Yeah.
And Super Mario Odyssey, I like Odyssey the best.
Really.
Yeah.
Mm-hmm. I think you and I have a similar interest in that because as I grew up, I really didn't like the 2-dimensional linear design.
I like the 2-dimensional linear design. Like I played New Super Mario Bros. On the DS, and that was pretty fun. Though I don't really have any reason to go back to it now that I'm done.
Yeah.
Like now that I've seen the credits, it's like, oh well, okay, that was fun. Bye. I'll move on to the other games. But honestly, even though I've completed the credits, that didn't. I still kept coming back.
Really?
It was like because just because you complete the credits doesn't mean there's all these other end game stuff and all these other moves that you didn't find on.
Yeah, the replayability is really high.
Yeah.
And there's like that other game where you could set a hat or feathers or something, where online where you can try to figure out like within a certain time limit like how that player placed that.
Luigi's Balloon World?
The balloons. Yeah, I saw a video on that. I mean, the guy that was playing it was really funny. He's a little inappropriate, I think, to school standards, so I can't suggest to you who it was. But I think upon inferences, maybe you know who we're talking about. But he showed me the beauty of that. I'm like, oh, so players can kind of make their own, even though it's confined to the
one world.
Yeah, one world or whatever the world is designed. It's just really cool, like that people could, like in their own way, create their own.
I watched a review of it, and it's like, yes, something more about it.
I really want to play it for that. It just seems like the replayability is really high, and I like that open world structure a little bit more. All right, guys. Does anybody want to share their answers? Like raise their hand. I can go over and see how close you guys were, and give you guys some extra credit. Yeah.
So what? 43.8, and I used the table. So.
I see. I think you're insinuating something. Okay. Do you guys have an answer collectively?
Wait,
what did you? That one's actually close. You guys are so ridiculous. It's too. Sorry. No, yeah, it's funny because I wrote you as a flame already. And I just gave credit to you. Well, so
This is way too high.
all right, we're at a. Do you guys come up with the answer? You're still working.
No, we were working together.
Oh, okay. You. Steven?
no, I'm doing
47?
You could add all those together and then multiply the answer by 2. I'm gonna try that.
Good job. Is this stuffy in here? Let me know if it's stuffy in here. Okay, I got the heater on, so. All right, guys. I think you guys recognize making rectangles was probably the optimal way to do this. Anybody have difficulty setting up the rectangles at all? Like in terms of what to set the heights at? No? No? Okay. Well, I kind of skipped some steps here. If I were to find the area though, the unit would have been milligrams per liters times seconds. I'm not asking you to do the liters because over here I crossed it out. I don't know why I did that, but if you guys pay close attention, I think some of you guys knew right away. The answer was given up here, and I think you guys were playing honorably by using only the data given in the table here. But the answer was given in the book as 44.8. So that's the actual answer. So if you guys got close to 44.8, very good job. Even within 3 units, I still gave you credit. Like if it was like you guys got 49, 47, or like a 40 or 41, still good. I think that's still a really good estimate. Okay. And then somehow they converted that to 6.7 liters per minute. I'm not exactly sure how they did that. And I've noticed that a lot of mathematicians create really fun problems, but they don't really pay attention to the units. And I think they should, or else the unit that you get sometimes is a good check to see if you did something right, but that's not a really understandable conceptual unit there that really works. So I have no idea where they got that unit from. Okay. That being said, I'm not going to have you guys do this. I just wanted to have this as a visual aid to maybe set up for this problem. But you guys did wonderful. Let's go on to your big handout here. This is probably going to be the crux of today's lesson plan. I want you to go on this specific page. It's 2-sided, but I want you to go on the one where it says left sum, midpoint sum, and right sum. Read very carefully the descriptions underneath left sum, midpoint sum, right sum. Then I want you to look carefully here. You can look at the math, but some of the notation might be, get confused by the notation. Look at the notation, try to understand it. You might be confused. You might not understand what's going on, but look at the visual more so. I really want you to look at the visual here. Read the prompt here, and then read the sums. And please try to tell me what the heck this all means. What's the difference between left sum, midpoint sum, and right sum? I'm going to give you guys a few seconds before you blurt it out. Right? So thank you. I won't choose you. Present. Did any of you guys get sick over the break at all? Yeah, it was horrendous. How long did yours last, guys? All right, good. I'm asking you because I'm still about a week right now in, and it stinks. Yeah. Did you cough a lot at night? Yeah, I cannot stop coughing at night. I don't know what's happening. Like I'm fine during the day, and then at night I just become, dragon. Just breathe fire at night. Yeah. No one in my house can sleep. How long did yours last, Joseph? A few days. Wow, you have a strong immune system. How about you guys? Anybody get? What? That's it?
Like I was really sick too.
Really? Me too. For that first day, but then I continuously sucked it. I don't know. That stunk. I got sick right at New Year's Eve too. We were gonna go all out that day, and then that didn't happen. I just stayed in bed all day. Anybody else? Ashlyn, did you get sick? Just like what?
Just for like 2 days.
You guys have immaculate immune systems.
At all.
Oh, you didn't get sick at all. All right, so you probably got the best immune system. No, forget that. Yeah, I never even got sick. All right, so Anybody got an explanation here? What's the differences between the sums here? I don't get left sum, midpoint sum, right sum. Huh? Okay, yes.
Well, so like there's the length of each rectangle.
Like the long side? The
No, like the short side.
Oh, the short side. Okay, yeah.
And like so, and for each of those lengths, you can either go on the left side of the rectangles, the
Okay.
right side of the rectangles, or the middle of the rectangles.
Okay, very good, very good. Anybody else also want to expand on that? Have their own way to explain that too? So, because that you might have reached some hearts there, or some minds like, oh, I think I get it now. But anybody else want to offer like another way of explaining that? So maybe there's like another quarter or half the class, or however many other students are like, I need another way to look at this. No? Any other way to describe what's going on here? Let's go back to our original problem here, and let's look at the rectangle I chose to create, this first one here. Notice that I made a rectangle and I made equally spaced rectangles, which all these sums kind of encourage you to do. They want you to make equally sized spaced rectangles to define the areas under the curves. But here, according to this rectangle from 2 to 4, a lot of students had issues with, I don't know which height to use. Do I use 0 height or 0.6? And that rectangle, what height did I end up using? 0 or 0.6. So starting from 2 or 4. Like, do you see what I'm saying? What was the height that I ended up using? 0 or 0.6 to find out the area of this first rectangle? I decided to go with 0.6. That's what I would consider a right sum. Meaning between these two rectangles here and here, or in this rectangle from 2 to 4, I had the choice to either use the height of 0 and 0.6 as the first area of that rectangle. So I decided to use what's called a right sum. Let's see if was I always consistent in doing that. Oh, actually, yeah, I think I did that the whole time, didn't I? Let's take a look at 14 to 16, this rectangle. So I got 14 to 16, and let's look at these two, or 14 to 16, these two values here. So I could have used a height of either 3.8 or 2.9. What height does this seem to be when I made a rectangle between 14 and 16? Which height did I end up going with? 3.8 or 2.9 to make the height of this rectangle here? Let me shade it in really quick. This one. Yeah, I went with 3.8. And if you think about it, on the two sides of these rectangles, I decided to go with the left-hand height. So that would have been what's called a left sum. You have a choice to either go with one of these heights. Are you going to go with the one that's relatively to the left of this rectangle or to the right? Why do you think I chose to go with the left hand or the left sum? If I were to go with 2.9, let's look at where the height of the rectangle would be here of this rectangle. I would have stopped all the way over here. What's the problem in using that as the area for that rectangle as opposed to 3.8? Doesn't follow the line. And what does that tell us about the area under that curve? Is it going to give me the full area under that curve? So Ashlyn says no. And I think that's correct. If I were to go with what's called, I think I'm jumping ahead a little bit, 2.9. I think 2.9 is right over here. I'm sorry. 2.9 is about up here, okay? If I were to go with the area of the rectangle for this guy, and this is where the curve is, I think I'm completely underestimating the value of the actual area under this part of the curve. because there's a little bit of the area that I didn't account for right there. So if I go with the higher height, which is about 3.8, I think that's a little bit more accurate, wouldn't you say? But that's the problem. It's going to get really confusing for the person setting up this problem. Which height do I go with? Do I always go with the left? Do I always go with the right-hand side? I don't know. So you guys, I think, already understand that rough estimating under these weird curves, you can't divide it up into multiple shapes. I mean, you can, but that'd be a lot of work. But probably the easiest way to do it and the most efficient way to do it is picking one shape, which is rectangles. And then you got to decide right from the beginning, which heights are we going to use? The left-hand sides or the right-hand sides or the middle? Let me show you what that's going to look like. Think I might go back to this. Okay, let's go ahead and flip over the page here and let's begin doing these Riemann sums. So pay attention here. We're gonna do it. We're gonna do a set of problems going from the left sum. Then we're gonna have a midpoint sum and then a right sum on this row. First thing we're gonna start with is the area under this curve. And then read the prompt very carefully. It says this is a f of x is equal to x squared. That's the function right here. Okay. Then it says between between x equals 1. So it'll be in between right here, x equals 1, then x equals 4. We're going to use left sum with 3 rectangles of equal length. Okay. And then notice, I know this is pretty tough to see. Does anybody recognize what this means here? What this weird kind of means? The sum of. Pay close attention to the notation here. There's this triangle x. Anybody change your delta x. This is a tough one. You might not know what f of xi means, but pay close attention. That means the sum, and then that means the space of x. In this space of x, or this delta x, what we're going to do is we're going to take your, it's in between x equals 1 and x equals 4. We're going to estimate the area underneath the curve from x equals 1 to x equals 4. Okay? And how we're going to do that is we're going to divide this area between here to here into how many rectangles? 3 rectangles. How are we going to space these rectangles out? Notice that your base over here, it was really convenient. I think you guys happen to see that the space of these rectangles, or the delta, what we would call the delta x, how big was the spacing for each of these rectangles? Yeah, it was 2. And notice that's what I did. I did 2 times the height, right? 2 times the height here, and then I did 2 times the in between for this guy is 2 times the height of this rectangle, which I think I chose as, I think that's a little inaccurate, but I said it was 1.4, and then I chose over here, I said the area of this rectangle is 2 times 2.7. That's a little inaccurate too. I'm sorry, you can't even see what I'm looking at, but we're going to do the same thing over here, but we got to figure out how big the spacing is going to be. So what you're going to do is you're going to take the farthest point of the limit of where you're taking the area, so that's 4, and you're going to subtract the lowest point at which we're stopping, which is 1, and you're going to divide it by the number of rectangles that we want. We want 3 rectangles. So if you did 4 minus 1, if you can do that in your head, that should be 3, and then 3 minus 3 is 1. That tells me how wide these rectangles are going to be. So from here to here, and conveniently, each of these guys is spaced. This is 0, 1, 2, 3, 4, 5. Each of these increments represents a value of 1 unit. So here's a rectangle. That's a space of 1. Here's another rectangle, 2, and here's another rectangle, 3. These are the bases. One that's going to be a rectangle. This is going to be a rectangle, and this is going to be a rectangle. And what I'm going to do now is now I'm going to show you where the left sum, where the middle sum, and where the right sum are going to come into play. What does that mean? Okay, so at this point, you actually have a choice of actual 3, but right now, visually, you could probably only think of 2 possible rectangles. I could make a rectangle that stops at x equals 1, the height of x equals 1, or I can make it stop at the height of x equals 2. Do you see the difference there?
Yeah.
So in the left sum, can you guess, though, which side I'm going to pick, the left or the right?
The left.
The left. So here what is going to, or here's what my first rectangle is going to look like. It's going to come up, stop at the left hand, or like on the left side, it's x equals 1, x equals 2, x equals 1. I'm going to stop the rectangle right here at x equals 1 at the height of x equals 1. And then I'm going to complete the rectangle by making the other side the same length. There you go. That is the first rectangle. On the next rectangle, we're going to do the same thing. This next rectangle, I do not go, the height of this rectangle is determined by the left-hand side of the rectangle, the left length. So this next rectangle is from here to here, 2 to 3. It can go up to this height or this height. But since we're doing a left sum, we always go with the left-hand side. All right. And then again, the third rectangle. So go ahead and draw that in. I'm going to go through the third and last rectangle with you in just a second. Okay. The third rectangle, again, from x, I know it's hard to see, but this is x equals 3, and this is the x equals 4. Again, the spacing is always 1, so this is 1 wide. This rectangle has a width of 1, and this rectangle also has a width of 1, because that's the equally spaced width that I've determined. That's delta x. Okay, that's 1. Just to reiterate. So I have a choice between the height of x equals 3 or the height at x equals 4. But remember, since this is a left sum, I'm going to go with the left side of the rectangle, meaning it's going to be stopped by the height of the left, like whatever the x value is on the left. So that is right here. I'm going to stop right there. And then I could shade these in if I want. And using the left-hand sum, this is a rough estimate of the area under the curve between x equals 1 and x equals 4. Now I just got to find the areas, all right? And let me show you what the math is going to look like. And then I'm going to kind of reiterate what all this means, okay? What all this weird notation means. So let's look at this rectangle one more time, this one over here. We know that, let's see, how should I write this out? Okay, I'm going to write it out like the height. Okay, so let's look at the height really quick. If I took the height of this rectangle, what is the height? Is it f of 1 or is it f of 2? Sorry about this here. Yeah. I actually took the function or the y value at x equals 1, not of 2. So I'm going to say this is the f of 1. So the area of this rectangle is the height of x equals 1 times the actual space, which is 1. And to find the area of this whole estimate under the curve, I'm gonna have to take the area of the next rectangle. You've already kind of done this before, okay? But we're adding some formalism to it. What is f of, or what is the next thing going to say? It's going to be f of something times 1, because the area of this guy is the width. That's 1. But what is it going to be the f of? 2 or 3? 2. Very good. And can you guess what the last one is going to be? That is the f of something times, again, another base of 1. It would be the f of 3. Okay?
That graph is not perfectly on the right numbers.
I think so because Steph
I think that
yeah.
too.
No,
when you put it not.
You totally got me. So like when I was going through this the first time, I had everyone do it by eye. Okay? And that's fine. You can estimate the height looks about 3.5, 3.6. This looks about to be a graph or like a height of about 1 if I estimate it. And they just substitute in f of 1 is equal to about 1 point whatever. But or since we know f of x is equal to x squared, like you were saying, just in your head, if you plugged in x equals 1 in here, 1 squared, what is 1 squared? 1. Yeah, so that would just be, oh, and actually before I go on, all these heights are being multiplied by a similar number, are they not?
Yeah, the same number.
So what I can also do is I can kind of look at it like I could pull out 1, kind of like, like reverse redistribute, kind of like reverse distribute, right? I take out 1, factor out 1 out of each of these numbers, and I could have a weird summation thing saying this so the total area is the base 1 time, and since they all have similar bases, it's going to be base times all the heights. And like you said, f of 1 is simply 1. What about f of 2 if I plugged in 2 into x squared? It's 4. That's correct. So the f of 2, if I plugged in 2 into the f of x, which is equal to x squared, that's 2 squared. 2 squared is 4. And then how about 3? That's about 9 as well. So if you want probably the best way to go about this according to the actual values, you probably want to just briefly plug in these numbers back into the actual function, okay? Because as you can see, my drawings were not perfect by any means. And then if you add these together, 4 plus 1 is 5 plus 9. In my head, that's about 14. The area is about 14. And let's go back really quick. Now, hopefully, this notation makes sense. The area should be the area is a summation of all the heights, f of x's, times the delta x, which is the bases, the equally spaced bases. Does that make sense? Because what you see is in the first line right here, that's the f of a various height here times the space of 1 plus another f of the next rectangle, the area of the next rectangle, which is a f of 2 times, again, the same base, which we determined as 1. And then over here, it's the same thing, f of, and notice that's x of I, so that could be x's at different points, is what they're trying to say, x of I, okay, whatever I is. A lot of variables here, really confusing here, okay? That accounts for all the different rectangles that you're going to take the area of. And then the sum is you just add them together. Does that make sense? Not too difficult to understand, huh? Okay, let's go the opposite spectrum over here. Let's try doing it with the right sum. You don't have to wait for me, but you can follow along with what I'm going through. So first step I'm going to do is I'm going to find out the delta x. I find that that's from x, and that's between x of 1 and x of 4. It's almost the same problem. It is the same problem, isn't it? But
in different ways. So.
Yes. So it's going to be 4 minus 1. And then I want 3 rectangles. So you divide it by the number of rectangles that you want to make. That's 3. So it's 4 minus 1 equals 3. Guess what? The base is, again, still equal to 1. What does that mean? The bases, remember, this, and this, they still have a base of 1 unit. However, what does that mean for the right sum? What is the difference between doing the left sum and doing the right sum? Well, I'm going to show you right here. This first rectangle, again, you have a choice. Do you want the height of this rectangle to be going on, or do you want it to go up according to the left-hand side or the right-hand side? This being a right sum, we can probably assume that you're going to pick, instead of going on the left heights, now you're going to go on the right-hand heights. Okay, so instead of f of 1, we're going to do f of 2. So now look at our rectangle. It's a lot bigger. So that first statement right there is going to be f of 2 times 1. That's the area for that first rectangle. A little bit different from what we had here when we went on the left-hand height, which is f of 1 times 1. Now for this first rectangle, I'm going of f of 2 times 1. And then we're going to add another area of another rectangle. Again, this rectangle is going to be, the height of this rectangle is going to be determined not by the left height when we're doing a right sum, but the right-hand height. So it's going to be f of 3. So I think that goes up to here. So I'm going to try to be a little bit more accurate here. Stops right here on this curve. I make the rectangle here. So the area of this guy is going to be f of 3. So is it the function of 2 or the function of 3? Well, the height is determined by the function of 3, which is up to here. So that's the function of 3, f of 3, times 1. That's the area of this rectangle. And that final rectangle should be right here. So it goes from here, from x equals 1 or 3 to x equals 4. Again, the height, so the base is determined already. That's going to be a space of 1. But the height is going to be determined either by the left-hand side, the left-hand height, or the right-hand height. So either x equals the f of 3 or f of 4. But since this is a right sum, we're going to go with the right-hand height, which is at x equals 4. And if you rewrite this again, I found out that the x's, you could factor on 1 out of, or the base value from each of these values, from each of these areas here, I could factor out 1. So it'd be factoring out 1 because 1 is being multiplied to each of these heights. And then within this parenthetical expression, I'm going to write just the heights are being added together. 1 times f of 2 plus f of 3 plus f of 4. And then you can either go by f of 2, you can kind of eyeball the height, or you can plug in 2 into x squared. So 2 squared is 4. 3 into x squared is 9. And then 4 into x squared is 16. I will add those up together. 4 plus 9 plus 13 is 16. I think I got about 29. Is that about right? Did you guys get that? I would say that the original, actually look at this. This is the same question, but I'm finding the area using 2 different methods. Could you say one is more accurate than the other? Remember, these are just estimates.
Not really.
How can you, why do you say that they're,
Like one's really under and the other is really over.
right? So as an estimate, I would say that this number here is an overestimate, right? Because you can see that the rectangles I made clearly go over the curve, which gives this curve way more of an overestimate of the area under the curve. In fact, these are areas that go over the curve. What about here? What's the issue with this estimate? If this is an overestimate, what would you consider this to be up here? An underestimate. Can you guess where we're going to go with this midpoint sum? I saved this for last because this is probably going to be a little bit more tricky, a little bit more difficult. Okay? All right. So same thing, same scenario, 3 rectangles between x equals 1, x equals 4. From here to here is where we're looking at. Same idea. So from x equals 4 minus x equals 1 divided by 3, that's going to give me a space of 1. There are going to be 3 equally spaced rectangles. 3. The only difference here, instead of going with the left height or the right-hand right, x equals 1, x equals 2, where do you think I'm going to take the height now?
The middle.
So in between, the midpoint between x equals 1 and x equals 2, what would you say that's about? That's x equals
1.5.
So in between here and here, you can just say in between here, or you could say at x equals f, or at f of 1.5, I'm going to say that's the height right there. I'm going to find out the height of the midpoint between x equals 1, x equals 2. I say this is x equals 1.5. The height of x equals 1.5 on the curve is right there.
2.
Could be some. I don't know what that is, right?
No, that's what color.
It's a little overestimate, right? It's a little bit of an overestimation, but it looks better than down here, I think. Okay.
And like there's a bit of an over, but there's also a bit of under.
Yeah. In the same
Balance.
in the same vein, though, this is an overestimate. At the same vein, this rectangle is also an underestimate because there's this space that I didn't account for. This blank space right here that I'm pointing to. I didn't account for the area under there, so it almost balances out, right? Okay, and the next one, I'm going to do the same thing. I'm going to do x equals from x equals 2 to 3 is another rectangle. And then I'm going to say the height is not at x equals 2 and not at x equals 3, but x equals 2.5. So I'm going to kind of visualize where x equals 2.5 here. I'm going to kind of move my pen up to where it would end up on the curve. That's going to be the height. Again, a little bit of an overestimation, but a little bit of an underestimation here. And then finally, so I'm going to write this. So far what I have is f of 1.5 times 1 plus f of, what is it? 2.5 times 1. And the last one is between 3 and 4. That's about f of 3.5 times 1. So f of 3.5, that's between 3 and 4. That midpoint's like right up here, I think. I think I might have completely overshot it here, but
12.
You got 12? You got about 12?
12.25.
Okay, all right. So I'm just going to draw visually what I got. It might not be as accurate. Before I'm doing any math, wouldn't you say that's a better estimation? Wouldn't you say visually speaking? That looks like, I mean, there's some spaces missing and there's some overestimations, but that's not bad. Midpoint's pretty good. I think that's a good middle ground, right? Pun intended. Middle ground between the left sum and the right sum. My suggestion again is not to go by the I, but actually plug in 1.5 into x squared. Did anybody do that already? It's 2.75. Oh, you're talking about the total area. Oh, you just want to get to the nitty gritty, huh?
And then 6.25 and then 12.25.
Okay, hold on. Let me ask in just a sec. Sorry, I forgot to rewrite this again. So I factored out the base of 1 out of each of these guys. So I have 1 times f of 1.5, f of 2.5, and f of 3.5. And then, Stephanie, could you tell me those heights once again? F of 2.25, okay. 6.25. 12.25 for f of 3, f of 3.5. And then in total, what did you get again? 20.75?
Yeah.
That is absolutely correct. I would say out of these three, the midpoint sum, Riemann sum. So these are all types of Riemann sums. The midpoint sum is probably the closest here. Do you think that in this case, the left sum was the underestimation and the right sum was the overestimation? Is that always the case?
I don't think so.
Do you guys think that's always the case, that the left sum is always the underestimation?
If it's curving downwards and you go from the left side, then it's over.
Can you show us visually what you mean by that, Stephanie? That's a little hard to do. Why don't you do it on the big board over there if you can? I don't know.
So what we had a curve like there's this.
Drop big too.
There's this. So if we do the left side, we're going to say that's the same, but like on let's say we're trying here, then if we're using the left side, then it's like right there.
Can you keep drawing some more squares or more rectangles for us to see, just so we can kind of visualize it? And then do it again on the other one. Yeah. Okay, so all right, go ahead and have a seat, Stephanie. Thank you very much. So I know it's kind of hard to see, but she has two different curves going on here. She has this left-hand curve that's going straight up, and the left sum, as you can see, always ends up in an underestimation. However, look at this curve. I know it's kind of hard to differentiate now because I told her to keep going with the squares, but look at this curve that's going downwards. She did left-hand sums as well, starting always stemming from the left side more. And then this clearly accounts to make an overestimation. So depending on your curve, you might get an under or overestimation. And usually a good middle ground is always the midpoint sum. What I want you to do now is try to do 7, 8, and 9 with a partner or on your own. Okay? So try doing that now. So read the prompt very carefully. Try doing it on your own. So read carefully. It says 5 rectangles of equal length or width. It says from -8 to 2. So what I would do is I would do 2 minus -8. So from 2 to -8. Oops, sorry about that. 2 to -8 right here. We need 5 equally spaced rectangles. So I do 2 minus -8 divided by 5. That's how you're going to determine the base of these rectangles. That should be 10 divided by 5. So these rectangles should have a base of 2. I'm going to draw that in. That's a rectangle right here, from here to here. This is a rectangle from here to here. This is a rectangle from here to here. Spaces of 2. If I did that correctly, you should see 5 different bases. Again, you can do this on your own. I'm going to help you at least with the first one, but go ahead and work on your own if you like. And then if I'm going to do the left hand sums, or the left sum, Riemann sums, then I'm going to do with the height between these two heights. I'm going to do the left height here for this first rectangle. What that's going to look like is that's the height of f of, let's see, that's the height of a f of -2 times 2 plus the f of, I'm going to do the next rectangle. So again, I'm going to go to the height of negative, or what is that? Sorry, that's -8, guys. I'm so sorry about that if you're following me. F of -8 times 2. Next one should be f of -6. Again, where's the height of -6 on the curve? It's right here. As you can see, this is a completely different case because the curve does not just go in one direction. It goes up and down, up and down. As f of -6 times 2, that's the area of this rectangle. Next one should be f of -4, which is on this part of the curve. So I should be getting a few overestimates now. So if you want to check in once in a while to see what your rectangles look like in comparison to mine, this is what they should look like so far. Going with the left sum, this is f of -4 times 2. because this has a base of 2. Next one is f of 2, I could already tell, times 2. F of negative 2 is right here on the curve. And then the last one's going to be the left side. So this height or this height, that's going to be the left height. So this is an underestimate. That is the f of 0, and that's it. That's all we're doing, f of 0 times 2. And if I were to rewrite that, that'd be 2 times f of negative 8 plus the f of negative 6 plus the f of negative 4 plus the f of negative 2 plus the f of 0. The tricky part is having to figure out each of those heights because the equation is much more complex than our last equation. Our last equation was simply x squared. F of x this time is x cubed divided by 8 plus x squared plus 3. So I would highly recommend using a calculator for this. I'm just going to use my calculator here. I think I would put negative 8 cubed. So that's negative 8 cubed. Oh, that's divided by 8. So, oh dear, that's going to be quite confusing. I'm going to put that in parentheses. Second, delete gives me insertion of parentheses here. Divided by 8 plus x squared, so that's 8 squared. Whoops. Eight squared. What else does that say? Plus 3, I think. Did you guys get 3 for the first one? Or no? Like that? I did. Yep, it is. Oh dear, that's 2 times 3. And then I'm gonna say dot because that's gonna be a lot of work on my end. I'm sorry, I'm a little lazy and I'm a little strapped for time. Anybody get a final area so far? 90? All right. 70. Let's see. Okay, so I do have a key. Okay. I'm gonna get myself out of the problem. Or I will post this online too for your notes. In fact, I've already made parts 2, 3, and 4 for this video. I'm gonna go over that in just a second, what I mean by that. But let's take a look here. Let's zoom in a little bit. Who said 70? Ashlyn, Gwen, Elena.
70 as well.
Very good job, guys. The answer is 70. You guys can keep going on. You guys don't have to look at the answers, but here's what you should get here, visually speaking. Actually, if you could stop for a second, which one would you say is the most accurate representation of the area? The left sum, the mid sum, or the right sum? Yeah, I would say the mid sum roughly. But what is more accurate between left and right? Left sum or right sum? I would say the right is a little bit more accurate. I don't know. Yes, maybe not. 70.
It used to go up and then down and then up again. Or more like, and for the left, more like down and then up. And then down.
Sorry about this, Stephanie. I just realized there's only a few minutes of class left, so I got to tell you guys a few things. Okay, so keep working. Go ahead and keep working. But if you can, please multitask and listen. On your cover sheet. Oh dear, this is getting a little slower, right? Actually, on the website. Let's go back to my website really quick. So I don't know if you guys were paying attention during the break, but my website looked a little crazy. Okay, so this is what I posted up for last week. Please make sure you've already watched at least the first 3 videos. Related rates, part 1, 2, and 3. There's a handout that goes with it as well, right here. Related rates worksheet and notes. I wanted you to print that out at home, and it has a key, and I wanted you to take notes on that. That was from last week. My intention was also to go through this whole thing I went through with you today, that first week, which I realized I made a mistake. This is clearly week 2 stuff. What we just went through today, come on, stop highlighting. What we went through today was what I was supposed to tape over the actual break, until I realized, no, we were supposed to go through this together in class. So this video that I'm taping right now is going to go into here, and then you're going to have a new section today saying week 2 videos with 6.1, and then part 2 and 3 and 4, there's still more to this I want to go over with you guys, have already been posted from last year. Last year I used to not tape my lectures, but now I do. Okay, so if that makes sense, today's lecture is going to be part 1. It's going to go up. That's about an hour long, and then I want you to watch the rest of these as well. Part 2, part 3, and part 4. Okay, and part 5. Sorry, the handouts that I just gave out, including a key, should be right here. So all the handouts that you needed, in, let's say if you want to keep them for some reason, but definitely the one that you're writing on right now is the one I want you to keep. The one that you're writing on right now is one I want you to keep, and there's a key to it. I've attached all the links right here, okay? The last thing that I wanted to go over was on your cover sheet. And also on the website, if you read carefully, if you want an extra credit before the end of the semester, okay, you can either do notes or you can do any of these sample worksheets I gave out. Okay, I think some of them have solutions, some of them don't, but you can work on these. Okay, that's for extra credit. Anything you turn in is extra credit. Here's some helpful little documents that might help you to study for the final. And you're wondering, final? Yes, it is cumulative, but here's the trade-off. The practice exam, I'm still working on. I got about, I think, 8 questions on there. Okay, so far. I'm trying to make questions that look exactly like the ones that they're going to be on your exam. Okay, not exactly like the numbers, but the numbers are going to be a little bit different on the exam. All right, but it's a Google Doc, so it's always up for editing, and I'm still adding on some stuff. Okay, so I have to make it a little easier. I don't know if this does make it easier, but I have a blank version right here, and then the other link right here is going to be only for solutions. Okay, so you can have 2 different windows open up while you're studying. I would suggest maybe you work on a problem here and there if you can, like a problem a day, a problem every 2 days or so. Okay, and then I guess that's about it. I want to go more over this stuff. All right, but hopefully my parts 2, 3, 4, 5, and 5 have all covered the rest of what I wanted to go over. Okay, Ashley, did you have a question? You can do both. You can tack on as much as you want. So I'll just be, yeah, you can have a huge grove of extra credit points. Okay, it's up to you. All right, guys, you guys have a great day, and thank you for coming.
I have my test.